Good afternoon. Welcome to Astrology. And so Jane Brockman is going to come up and introduce our speaker for today. If you have a cell phone, could you please silence it? It would be great. Zoomers, please stay muted. If you do chat, please do a chat to the host, not to the group, so it doesn't appear on our screen. And if anybody has any problems with listening to sound or anything, headphones are good, or the ear pods, or else you can go into your audio on the left side of your screen in Zoom and do your audio settings if you have a hearing, if you can't seem to hear sometimes. Okay, Jane, you ready to go?
Okay, all right. Yes, this is working. So welcome to the astronomy course and in ILR. Yes, it was, and thank you all for coming out on such a cold day. Yeah, great. Wait for just a minute where there's more people coming in. Okay, yeah, so there have been so many new exciting discoveries in astronomy over the last few years. They're really changing the way we think about our, glad it's not mine. I'll, I'll do mine in a minute. There's so many new ways of thinking about our Earth and the solar system and in fact the universe. It's really complete new okay. Okay, and so there's lots and lots of exciting new things that are going on, but I, for one, actually didn't know enough about astronomy to be able to interpret or understand what some of these exciting new discoveries really were. And that got me to talking to Jane Wood, who, as many of you know, is an avid amateur astronomer. And she kind of, between the two of us, talked about a lot of different issues. She kind of gave me the nerve to think that maybe we could put together a course on astronomy. And in fact, she's been a huge help in getting the speakers and talking about astronomy. So to get us started, Jane will be our first speaker. She, well, her interest in astronomy started when she was a small child and was out camping and in a place in Canada where you could see the dark sky and you could actually see meteors going across the sky. And that just kind of turned her on for the rest of her life about astronomy. And some years ago, 20 years ago or so, she ended up in St. Augustine and joined the Ancient City Astronomy Club, and then went out chasing meteor showers and rocket launches and whatever was up there, right? Exactly, whatever was up there. And so she's going to tell us today about what's up there. Yes, about the sort of her ride across the universe. So she had done some other things too, like go to college and work at Oxford and some things like that, but she thought that was too boring to mention in the introduction. So Jane's Starship Voyage.
How's the audio? It is? You can hear in the back? Okay, good. Yeah, we're going to do that. Thank you for reminding us. Yeah, yeah. We'll have a little mood lighting if that's okay.
Can you get sound?
Not very well, no. I could hardly hear Jane.
I can't even get there because it tells me there's no meeting scheduled. And it made me type in a password.
Well,
You needed the secret code. How's that? Audio coming through? In Zoom land as well? Okay. Well, first, we need the big picture here. The cosmic picture. Yeah. There you go. You're in. That one's good. You can just leave it right there. Perfect. All right. So, first of all, thank you, Pam, for all you do. See what she does? Getting things straightened out here. And thank you, Jane, for the introduction. Very generous. And I appreciate your inspiring and making happen.
I'm
this
trying to
course
do
in
that
astronomy.
now.
Okay, we're rolling. All right. I appreciate you making this happen, this course in astronomy, because since my coming here to Okamic, I have been hoping for a course like this, and now here it is, and I am happy to see you all because there are things I want to show you, true stories about the universe. And anyway, how fine to have company when exploring Zoom. Is that what we're exploring here? Okay, listen. If there's problems, I can always do a Zoom recording on my own up in my room and pass it to you, and you could send it up instead of pausing. Would that work? Okay, signal acquisition. So yes, it's nice to have company when exploring the beauty of the cosmos. And today we will look at how our little planet fits into this whole enchilada, but to do so, there's a catch. We need to leave our familiar rock called Earth and launch into the great unknown. We need to go on a Starship voyage. Okay, now we have no acquisition on the clicker. Yay, this what we need to do. We need to go on that Starship voyage where we will soar across the universe and see all the directions our planet moves. And to give context to our journey, here is the entire span of time for our universe. As you see across the bottom, all 13.8 billion years, starting on the left when the universe kicked off with a big bang, followed by cosmic inflation, where everything expanded really fast, and then galaxies formed. And somewhere in that purple band is our own galaxy, exerted out here, the Milky Way, that's within that purple band. And then within the Milky Way is the solar system and our vulnerable little planet Earth, bringing us right up to today. And dare I say, this span of time, it reminds me of spider webs. The metaphor being that the middle is the Big Bang, where life of the universe began, followed by that empty space of rapid cosmic inflation, and then on and on and on, where stars formed into galaxies. And somewhere out there on that great cosmic web, all laden with dew, is our own little drop of dew, Earth. And this is just background to say that today we will look at our place in the universe, and that involves Earth's major movements through the cosmos. And then we will look at Earth's more subtle moves. And then we'll just dive into the beauty of space, the beauty of the cosmos, all within the theme of shadows in space. Now, on our journey, we need to know how to measure distances, right? I mean, on Earth, we roll in miles. In space, we roll in light years. This image goes 13 billion light years deep. And a light year is simply the distance light travels in 1 year. That's it. And that is 6 trillion miles. That's 6 with 12 zeros after it. For example, Earth is 4 light years from our closest star, Proxima Centauri, meaning that light from that star takes 4 years to reach Earth. Earth is 2.5 million light years from our closest galaxy, Andromeda. And you remember Andromeda because it's the first image we looked at today. Light from this beautiful spiral galaxy takes 2.5 million years to reach Earth. However, astronomers predict that we are on a collision course with that, and that in 4.5 billion years, we will either collide or will sideswipe, or because of the great distances between celestial objects, we could just slide right through. So that's it. That's all we need to know. School is out and we are ready to launch into the great unknown. So let's go. We head to the hammock to find a good launch site, right? How about one of those pondside terraces? We set up our Starship, we lock and load, and with the tip of our hat, we blast off. Moments into flight, we see our fair state, we bid adieu, goodbye Gville. Soaring higher, we see the anvil tops of thunderclouds on the surface of our planet. Pulling away, we see our full planet in all its glory. Further on, we start to see the first two. Oh, you know, Pam, you can always click that little minus sign in the upper left of that image, or does that blow everybody away? That's good. So you can see the first two movements of Earth. At the very bottom, you see Earth rotating. Clicker control. Yep. Thank you. Wow. This is really far, deep space, right? There we go. I think we're good, Pam. There's rotation, the first movement where Earth spins on its axis once every 24 hours, bringing us night and day. At the same time, we have Earth revolving around the sun once a year, bringing us the seasons. And Earth is just one of a number of planets revolving around the sun, all within the solar system. Starting closest to the sun, we have the rocky planets, the rocky ones. That's Mercury, Venus, Earth, and Mars. Then, you see, comes the asteroid belt, that ring of irregularly shaped debris, objects. And then come the big ones. That's the gaseous giants with their massive gravity. That's Jupiter, Saturn, Uranus, and Neptune. And notice that all 4 of the gaseous giants have rings, right? So Saturn is not the only planet with bling. And sadly, no Pluto. The 9th planet was kicked out of the family and cast into this Kuiper belt, this outer ring of icy debris. Now, what's the next structure? Where does the solar system reside? Because everything's been within something, right? Where does the solar system reside? Well, we know because on clear, dark nights, we can see the next structure foaming across the sky, the Milky Way, as captured here by my friend Paul Jones, who is clearly standing on Earth, of course, and he is looking, okay, the Milky Way is disc-shaped. He's looking in toward the center of the Milky Way. See that light area there? That is our galactic core around which we and everything in the Milky Way revolves. NASA illustrates the Milky Way here, and we live on this disc shape. We live in an outer spiral arm. We are tucked into the Orion spur. You can see it there. We're tucked in there. And the Milky Way is a barred spiral galaxy. You can see the bar. It's that gold oblong area in the middle. And there is a black hole in there, a supermassive one. And you can see the spirals winging around the outside. And the Milky Way is one of 30 plus galaxies revolving around a structure called the local group. Could they have thought of a more boring name than the local group? But here we are, 30 plus galaxies, and the biggest one happens to be us. You can kind of see what looks like it's in the middle. It's not really the middle, but here it is bigger, the Milky Way. And the second one is our neighboring Andromeda, up there, cigar-shaped, upper left, Andromeda, and then down and to the left you see Triangulum, another really pretty spiral galaxy. So all these galaxies revolve around the local group's center of gravity, all right, which is about midway between Andromeda and the Milky Way. And you know how these structures have been disc-shaped and we've been revolving on a common plane, like in the Milky Way and the solar system? Well, for the local group, instead, all the galaxies are revolving more the way electrons revolve around an atomic nucleus. Different planes, every which way. So is this making sense? Right? Like these structures are nested within each other. Everything's nested within the next structure up, like Russian nesting dolls, where the little ones nest inside the next one and on till they're all inside the great big one. The metaphor is Earth. Nest is within the solar system, which is within the Milky Way, within the local group, and on until everything's in the universe. Okay? That's important. They nest within each other. So guess what? Only 2 more structures to go. And the next one is my favorite, the beautiful Laniakea supercluster, which is 100,000 galaxies, including our own, including everything in the local group. We are inside here. And you look, you can see the gold areas are the galaxies, and the shadowy blue are the voids. Now this supercluster was identified only recently by Brent Tully and his team of astronomers working out of University of Hawaii. How about that for a sweet gig? Exploring the cosmos from Hawaii. This was in 2014. And Tully and his team named this supercluster Laniakea, which is the Hawaiian word for immense heaven. Here's another view of Laniakea, this one showing motion, where you can see the red dot signpost for our local group. And we, the local group, and most of these other 100,000 galaxies are moving along these golden paths toward that intersection in the upper left. That area draws in galaxies. They call that region the Great Attractor. And I would love to leave us here in Laniakea, my favorite structure in the universe. But to be true to our mission, we need to go one more level. So zoom out and find Pisces Cetus supercluster complex. I know it kind of sounds like a big condo complex in Miami, but but that's what it is, and it is 1 billion light years wide. You can see the yellow area in the center. That's us. That's Laniakea supercluster right there. That's us. And this is a network of voids and galaxy filaments. All right? Voids, you can see them. 3 are noted in red, and there's plenty other voids. And they are bordered by galaxy filaments, which all that is it's just lots of galaxies, all walls of galaxies. And they come out looking like, these filaments. So they're galaxy filaments. And this, our supercluster complex, is one of a number of superstructures like this that hang out side by side, no longer nested now. And together it looks like this. So you see all the voids, you see the galaxy filaments as they come together in the bright nodes. I mean, this is what, and these are all these superclusters here, which really kind of blows my mind, because I always thought of the universe as stars and more stars going on and on into forever. But it's this. And remember when we were looking at the spider web and we talked about the great cosmic web? Well, they call this the cosmic web. How big is the cosmic web? It spans the ultimate level, as big as it gets. The cosmic web spans, and in fact is, the universe. The whole universe, all 93 billion light years wide, and that's just the part that we know about. So there we are. And where does it leave us? Well, it kind of leaves us, drifting through these voids, bumping up against walls of galaxies, and we've kind of lost our bearings. But we know the only cure for being lost in space is to remember where we all came from and get ourselves back on solid ground. But we need to know our address to get there. But we know we have been through all the structures of the universe where Earth resides. So we set our course for our address, which is Oak Hammock in Gainesville, USA, on planet Earth, within the solar system, which is within the Milky Way. And that is where? That is within what? That structure with the boring name? Yeah, the local group, you guys know. And that is within beautiful Laniakea, which is within the big condo complex in the sky, Cetus, and it's all within the universe. So with our course set, we fall through Cetus supercluster complex. We dive for that yellow area, which is Laniakea, and we cruise on over to that red signpost, which is the local group where we pass by all the other galaxies and go for the one we know and love, the Milky Way, and we head on over to the Orion Spur and find our Milky Way, where we see our small blue marble Earth. And watch out, because here comes Florida, and in the blink of an eye, we land where our Starship journey began. And we are on solid ground. We are home, but we are changed, right? Because we know the Earth does not stand still. It is moving through all these structures that we just traveled through. It is moving and turning, and with all that whirling and twirling, do you feel dizzy yet? Which puts me in mind of one of my favorite people, Albert Einstein, who said, life is like riding a bicycle. To keep your balance, you must keep moving, and so it is with celestial orbs and galaxies and superclusters. We are all in constant motion just keeping our balance in the universe. So, with our journey complete, let's pause, take a breath, because we are about to shift to a whole new region. We have been looking at major movements. Now we are going to look at Earth's more subtle moves. These are moves imperceptible, yet they have impact. These subtle moves are many. I picked out 3 that I thought you would like. So starting with axial precession. The metaphor here is the slow winding change in Earth's axis. Okay? And it goes like this. Here's the Earth. The red imaginary line is our axis. The northern part is pointing toward our North Star, which currently is Polaris. But the axis over time points to different parts of the sky. All right? All around in that circle, lending a wobble to the Earth like a child's top. Or remember gyroscopes? It's like that. And it looks like this. Here is our axis pointing to Polaris. And this is what happens. Now, we don't notice this movement because it happens over a period of 26,000 years. Okay? And this is the impact. We have our axis now pointing to our North Star, which is Polaris. It's been Polaris all our lives. But halfway around that 26,000 year cycle, our axis will be pointing toward the way brighter star Vega. Okay, a mere 14,000 years from now. Now, in the same way, the stars behind the sun also change. All right, now let's say we're standing on the North Pole and we're looking straight up and we're looking at Polaris and we see that circle emblazoned across the sky. And that circle shows all the constellations that our axis will point to. Big circle, stars and constellations. You see it in your mind? You see it? Does it look anything like that? Because there is that 26,000 year cycle where our axis points, and we are now at the very top where our axis points toward Polaris. Do you see that just to the left of the year 2000 at the top? Moving left, you see in the year 4000, our North Star will be Gamma Cephei. And then halfway around, our North Star will be the way bright Vega. Maybe not right on the line, but Vega will be up there. And then the same thing happens with the constellations behind the sun. They change. Think about astrology. A big part of that practice is sun signs, right? So your sun sign is the constellation that appeared behind the sun at the time of your birth. Could be Capricorn, it could be Sagittarius. Well, all of that, because of this axial precession, all that is changed because the Babylonians defined astrology more than 2,000 years ago. And since then, it has shifted. Okay, now, for those of you who are tied to astrology and the sun signs as they are presented in the newspaper, it's okay. But just know that you are using what's called tropical astrology, calendar-based. Tropical astrology is based on the calendar, so anybody born at the end of the year will always be a Capricorn, even, 14,000 years from now. As opposed to sidereal astrology, which is based on the actual positions of the stars and the constellations. Sidereal meaning of the stars. So let's look at how our sun signs have changed. Here you recognize, you know where you are here. You can see Capricorn at the top, the end of the year. That's tropical astrology based on the calendar. Here are our sun signs based on the stars, the actual positions. They're based on reality. So, for example, I was born the last day of the year, December 31st, which pleased my daddy no end because he got to deduct $600 deduction on his income tax that year for me hanging out for a couple of hours. And astrologers say I'm a Capricorn, but the sun was in front of the constellation Sagittarius on the day I was born and every birthday thereafter. So in reality, I'm a Sagittarius. Okay, now some of you will actually still have the same sun sign, but the vast most of us will have changed. And you'll notice an additional sun sign here, an additional constellation, second from the bottom, Ophiuchus, because in fact, the sun passes in front of Ophiuchus's foot for those few weeks. Anybody here born December 29th to November 29th to December 17th, or the first? Okay, great. Well, at the next cocktail party, when some escapee from the 60s saunters up to you and says, "Hey man, what's your sign?" you can tell him Ophiuchus and start a real conversation. Okay, that is axial precession. So let's look at the next subtle move, which is lunar nodal cycles. The metaphor here is the moon is that white area, and it's slowly changing orbit. And to talk about lunar nodal cycles, we need to board the Okamic bus and drive to New Mexico, where we will stop at Chaco Canyon, a small archaeoastronomy site there, and we will go inside this cave and find 3 petroglyphs upon the wall, carbon dated to the to the decade of the 1050s, which is the decade where an extraordinary astronomical event occurred. In 1054, a supernova explosion that was so bright it lit up the night sky for weeks. Remnants of this explosion are visible today in the beautiful Crab Nebula. This is an expanding shell of gas and dust, remnants of that explosion. So you can see on the cave wall, the petroglyph, there's a starburst. That is the supernova explosion. To the right is a phase of the moon, which is the same moon phase as recorded by the Chinese on day 1 of this supernova explosion. And the petroglyph on top, shaped like a hand, that's the artist's signature. So one other stop at Chaco Canyon, we will see the discovery of the sun dagger. Here are 3 big rocks that fell off the mesa a long time ago. More recently, an artist was up there having her lunch, and she decided to explore behind those rocks. And she found on the wall this petroglyph, a spiral. And she found in time that on June 21st, the summer solstice, that sun dagger came through the crack in the wall and cast perfectly down the center of the spiral. And then on winter solstice, December 21st, 2 shafts of light came through 2 cracks in the wall and perfectly bordered the spiral. And it was also found that if you press your cheek against the center of that spiral and you look out that crack in the wall, you will see on that narrow slit of landscape, you will see the position on the horizon, the position of the northernmost moonrise. Okay, so we know the moon rises in the east and sets in the west. But what happens is on that rise, it rises just a little bit north and then a little bit south, kind of oscillates back and forth every 18.6 years, which happens to be the exact number of turns in that spiral. Yeah, counting up a ridge 1, down a ridge 2, up 3, 4, 5, out to 18, and then a little bit more for 18.6 years. Okay, so why does that happen? Well, it is lunar nodal cycles, which simply are, you see the orbit of the moon there? You see how it's slanted with respect to Earth? Okay, Earth's orbit. It's slanted, and that light blue area, that's slanted up now, right? And then it slants down, and then it slants up and down. It oscillates every 18.6 years. That is lunar nodal cycles, 18.6 years, the number of years between that oscillation, which happens to be the number of years between the northernmost moonrise and the number of turns in the spiral on the wall. So that's lunar nodal cycles. And we have one more subtle move. Okay, it's called axial tilt, and we dealt with the axis before, axial precession. Remember where the axis made this major sweep across the sky, around the sky. This is simply a little change in Earth's tilt. The tilt of Earth is 23.4 degrees. Okay, let's say this is the orbit of Earth all around the oak room floor, and I'm the Earth, and I'm standing here. Let's say we have no axial tilt. It's just going to be straight up and down like this, and life would be really boring because everybody on Earth would have 12 hours of light and 12 hours of dark all year round. But because we have this axial tilt, 23.4 degrees, we have a change in lengths of day and a change in seasons all year round. And it looks like this. Okay, so there up top, that's dealing with the angle up top. There's our axis pointing out there. That tilt, now remember, at the same time, that axis is making that big sweep for axial precession. But right here, it's just a change in axial tilt between 22.1 degrees and 24.5. That's less than 2.5 degrees. And that change happens once every 41,000 years. Yeah, so you want to see it? Okay, let's look. Okay, hang on to your seats, because here it comes. Wow, okay, big change. You want to see it again? All right. Look at that blue axis sticking out up top. Okay, watch that part. There it goes. And you'd think that because of that little change over a long period of time, there would be absolutely no effect. But you know, the Tropic of Cancer, that line of latitude going around the Earth, it goes through India, it goes south of Florida, that Tropic of Cancer is the northernmost position on the planet where we can see the sun directly overhead. We live just north of the Tropic of Cancer, so we never see the sun directly overhead. But because of this change, this little change in axial tilt, our Tropic of Cancer is heading south at 49 feet per year. It doesn't look like 49 feet because telephoto lens tends to shorten the appearance of distances. But in fact, it's 49 feet per year heading south. So I wanted to find a good illustration for you of the tropics of Cancer and Capricorn. And the most lovely one I could find is on our very own globe in the fireplace library across from where we get our mail. Here we have the African continent. Every country cut from a different kind of stone. Same thing on the other side. And you can see it's tilted 23.4 degrees. Although I can tell you, the globe doesn't naturally tilt that way. To get that tilt, to get that shot, I had to stand on one foot. I had to hold the tilt in place with my other foot and capture the shot. But I wore black socks so my foot doesn't show. And so there we are, 23.4 degrees. There is the Tropic of Cancer, 70 miles south of Key West, and the Tropic of Cancer, south of the equator. Both of those tropics, they are moving toward each other at 49 feet per year. They're going to go toward each other, and they're never going to meet because then it oscillates back up and then together, back and forth. As we saw on that lonely highway in Mexico, in the next 9,800 years, the Tropic of Cancer will move 91 miles. And I am shocked that we haven't seen this on the front page of the New York Times. Really, because, can you see the headline? Tropic of Cancer heads south. That's news we can use. So that was axial tilt. And hello, universe, which is backdrop to say that for subtle moves, we looked at axial precession every 26,000 years. We saw lunar nodal cycles every 18.6 years. And we saw axial tilt every 41,000 years. Yeah, so those are subtle moves. And now, we've done subtle moves, we've done the major movements. Let's just kick back and enjoy the beauty of the cosmos. But the cosmos is big. We need to narrow the scope. We need a theme. How about shadows in space? Starting with solar crescents. As you can see here, we have a total solar eclipse in progress, and you see those solar crescents narrowing as the moon moves across the sun. Until, for those in the path of totality, everybody gets really excited because the sky grows dark, temperatures drop, birds go silent, and crickets emerge. In the 2017 total solar eclipse, we observed it from western North Carolina. And among our group, this one gal had a dog that just loved jumping all over everybody. Well, when that moon eclipsed the sun and the sky grew dark, that dog, just like those birds going silent, that dog just lay down on the ground and went to sleep. So here's the same total solar eclipse. And imagine being up really high, like as high as the International Space Station, and you're looking down on Earth during a total solar eclipse. What does that look like? What does Earth look like? Is it all in shadow? Or is there a long, narrow shadow along the path of totality? Or is it simply a shadow of the moon cast upon the planet, and everybody in that shadow is enjoying a total solar eclipse? And that circular shadow just moves across the planet. This one grazed Australia. So you would imagine that aboard the International Space Station, we call it the ISS, that crew members have a pretty fine view up there looking down on Earth, seeing those shadows move across the planet. And do you ever wonder what that's like, what Earth looks like up there? Are you curious? Well, let's just go aboard and find out, because we haven't been off the planet since our Starship Voyage So let us go on board where we find crew members just floating around the breakfast table, sipping their meals from pouches. And see the gal on the left? That's Sunita Williams, my favorite astronaut. And here she is, getting ready to don a suit and head outside to perform maneuvers. Out the door she goes with the sun appearing at her fingertips. And well, this, by the way, adds to her more than 50 hours walking in space. So imagine she has a pretty nice view up there looking at our planet. But you know, the view inside the ISS is not bad either. How about this for a room with a view? This is the ISS observation module. They call this the cupola. All right, back to our crescents here. Solar crescents. We saw solar crescents here at Okamic projected on our boardwalk. The backstory is, you know, when you're walking along and you see tiny circles of light upon your path, well, those are projections of our sun, the light coming through the gaps in the leaves, the narrow gaps, which act as apertures and project an image of the sun upon our path. Same here. Sunbeam coming through the narrow gap in my bedroom curtains and projecting an image of the sun on the opposite wall. And in the living room, projections of the late day sun. So it is walking along, seeing those tiny circles, projections of the sun. So what happens when we're walking the same path and there's a solar eclipse going on? What's that going to look like? Yeah, like this. All right? And this is our boardwalk. Solar crescents projected on the boardwalk. And as we saw on April 8th, 2024, when a group of us gathered on the boardwalk across from the Commons, and with our NASA-approved solar glasses, we viewed the moon moving across the sun. It was not a total solar eclipse. It didn't grow completely dark, but we did see those crescents. And I brought along 4 kitchen colanders so we could view projections of that crescent on the boardwalk through the tiny holes in the colander, which act as apertures. And so we had some fun. Here are Ann Webster and Henry Logan projecting crescents upon the boardwalk. All these little holes, all those little bits of light, those are crescents. Here you can see closer up, crescent shapes. And y'all know Ken Rand, innovative as he is, he poked holes in his shopping list and projected crescents upon his junk mail. As you can see, 4 tiny crescents. So yeah, so that's solar crescents. And oh gosh, let's see, what time is it? Are we good? Oh, great, because I really want to show you this. These are shadows in deep space. Shadows we've been looking at are inside the solar system. These shadows are in deep space. And we will start with the cosmic bat nebula. You see the bat? You see him with his pointy ears and his sharp teeth. And ironically, this sinister looking deep sky object is lit from within by a stellar nursery, tiny young stars casting that glow. And I really wanted to show you this because guess what? This dark nebula resides in the constellation, you know it, Ophiuchus, that 13th constellation that the sun passes through. And this dark nebula is it's just filled with shadows. Sky and Telescope describes this nebula as cosmic dust clouds fashioned by galactic tides, shadowing the stars that lie beyond. Yeah. And this is the last one. This is a protostar, a young star. Okay, it's brought to us by the James Webb Space Telescope and brought to us by shadows. This young star is a mere 100,000 years old, and you can see it's right in the middle there. It feeds off of surrounding gas and dust because young stars just love gas and dust. It's their favorite food. And the hourglass shape comes to us from shadows cast by material ejected by this growing young star. So you can see how shadows help sculpt the shape of our deep sky objects. So shadows from clouds that never reach the Earth as backdrop to say that today we covered major movements, Earth's major movements within the structures of the cosmos, including the beautiful Laniakea. And then we talked about subtle moves, right? You know them. Axial precession, lunar nodal cycles, and axial tilt. 3 of them. And then we looked at shadows in deep space, and we went aboard the ISS, and we saw projections of solar crescents upon our boardwalk. And the thing is, all of these observations were made from the perspective of Earth, appearing here rock solid. But really, are we so solid? Remember this image? You guys remember, right? This is called the pale blue dot. See that shaft of light? Okay. Halfway down is a little white dot. That's Earth. Here, can see it better that way. Okay. When Voyager 1 departed the solar system, having completed its mission, NASA commanded the spaceship to turn its camera around and capture one last shot of Earth, as recommended by the astronomer Carl Sagan, who later wrote about this pale blue dot. He said, that's here, that's home, that's us. On it, everyone you love, everyone you've ever known, every human being who ever was, lived out their life on this mote of dust suspended on a sunbeam. And if that doesn't make us all connected, then what does? Because here we are, living together on our mote of dust in the Milky Way, just the right distance from the sun to keep us warm, and just the perfect axial tilt to bring us seasons all year round. So thank you. I hope you enjoyed our journey through the stars.
Right. Thank you very much. Questions? Anybody have any questions? All right, we have quite a few here.
Is there going to be a test on this at the end of the?
When you say something in here, you need to put it quite close and swallow it. Yeah, it should be like this ice cream cone that you're eating type thing. Okay, but yes, we heard it.
Jane, isn't there also another movement, which is the expansion of the universe?
Yes. The Earth, the universe, the Earth within, and the universe is expanding due to what they call dark energy. Dark energy, we can't see it, but it causes the universe to expand, and not only that, to accelerate that expansion. So at the time, we are expanding. And then there's different, cosmologists have different theories on what happens with all that, but that's another story. But yes, absolutely, Neil.
Jane, thanks so much. I feel like I had a university course in an hour. And I wanted to ask you if you have any comments about the stars in alignment coming up on the 21st.
The planets.
Sorry,
Yeah.
planets.
Yeah. Planetary alignments are magnificent for a number of reasons. And one is just because of, wow, they just happen to be all lined up. The picture I showed of the solar system, they were all lined up there. But that's not how they hang out. I mean, it looked like they were just lined up for a family photo or something. But no, actually, they have their own orbits and their own speeds. So planetary alignments are wonderful for the miraculous timing, and also because it's so accessible. We can go out there naked eye and see Jupiter, Saturn, Mars, sometimes Mercury with naked eye, and see them all in a line. It's so cool. Yes.
Thank you for the Starship Voyage.
Oh, you're welcome.
I have an Earth tilt question.
Yes.
At the South Pole, every year they go out and they relocate the geographic South Pole by about 30 to 33 feet. Is this an Earth tilt, or is it, as I've heard people say, the shifting of the 2 miles of crusted ice and snow above the South Pole shifting against the Earth, or both?
Well, it's so interesting that you bring that up, because that's one of the subtle moves, is the change in the magnetic North Pole. It's moving significantly, and this is not equivalent to that. It's not. There's not a cause and effect. They're two different movements, and it's unbelievable what effects there are to make these movements. I don't know. Is there any way to bring this up, like where we left off? If we have to go through the whole thing, no, we don't need to do it. But I can just show you some of the things that right where you are. If you could bring up the end, bring up that end, and do full presentation mode. Yeah, you got it. Slideshow from the start on the left. Yeah. Oh, it put us in the beginning. So that's okay. Nope, it's you don't want to go through it. So it's interesting, all the influences that make for these subtle moves. I mean, everything from earthquakes, the way our magnetic core slogs around back and forth, and then Jupiter's a bully with its gravity. Those massive planets will affect our movements too. Yes.
Thank you. This was so much fun, and your images were spectacular.
Oh, thank you
My
very
question
much.
goes to the beginning of your presentation, our place in space, and if the theoretical, or if the nesting analogy or metaphor ends with the Laniakea supercluster, what, if any, relationship do the superclusters have with each other? Thank you.
Yeah. Well, you've got Laniakea, and then Laniakea supercluster is within the Pisces supercluster complex. So that's the big one. And then, yes, the other large structures, many of them supercluster complexes, reside next to each other. So you're asking about the relationship between them. They relate to each other the same way objects do within our universe, within our Milky Way, within our day, within our solar system. And the gravity affects each other. Our momentum affects each other. So, yes, there is a relationship. Yes. Oh,
Yeah.
hi. Yeah.
Pluto wasn't really banished as a planet. it was downgraded in status or rank to a dwarf planet, one of 2 in the solar system.
Very sadly, that's right. Pluto lost its status as a planet and became thrown into the category of dwarf planet. There are three requirements to be a planet. And one is you need to be revolving around the sun. The second is the object needs to be big enough to have enough gravity to form a sphere. All right, but it can't have so much gravity that there's, nuclear fusion activity in there. So it's got to be that place of proper size and gravity. And then the last one is planets need to have orbital dominance, which means I call it clear the hood. They clear their neighborhood. They have a path of their own. They've cleared it out. They own that path, and Pluto doesn't. And that's why Pluto went to the Kuiper Belt.
All right, well, it's 2:30, so we probably should end. If others have questions for Jane, please come and surround her and ask her more questions. I know I have a few questions for her. So thank you very much. Next week will be James Albury, who is from the Kika Planetarium, and he's also a very interesting, entertaining speaker. So see you next week.